Hi, I'm Mr. Huber, and in this video we're going to look at problem 3i. Rewrite each function in factored form and find its zeros, y-intercept and vertex. Sketch the graph qualitatively. Now look, this is the first one that has a number in front of the x squared other than 1. So this is in fact a vertical stretch and it's a happy parabola. All the others had a 1x squared. All the others were original parabolas and maybe translated to the right or left, translated up or down. But this one is the first one that has a vertical stretch. And like in these exercises up here, it's a bit more difficult. So look, f of x is equal to 3x squared plus 16x plus 5. Well, without the brackets here. Now we need to factor this one. So f of x is now brackets times brackets. Now look, the 5 is easy here because it's 1 times 5 or 5 times 1, same thing, okay? But then the 3, you have a 3 in front of this, in front of your function. So that could be, the 3 could be 1 times 3 or 3 times 1. So you could start off like this, 3x and x. Well, if you multiply these two, you get 3x, obviously. And you could then here add a 5 and a 1. And here you could do more or less the same thing, 3x plus 1 and x plus 5. Now, which one is it? Because when you do this, you get 3x squared. This times this. This times this is 3x. This times this is 5x. And this times this is 5. So the last one and the first one are okay. Now this is 3x squared plus 15x, this times this, and then this times this plus 1x plus 5. Here again, the last one and the first one, they're correct. Now look, when you add these up, you get 8x, and here you get 16x. So here, this one's correct. Here, this one's not correct. Not what we want. So it must be this factorization, okay? So look, whenever you have a number in front of your x squared, normally you're going to use another method. But well, if the numbers are not too difficult, and in this case they are prime numbers, that makes it easy because you only have one possibility, 1 times 5 and 1 times 3. But then you have two possibilities here. Well, either it's 5 and 1 or it's 1 and 5. And you need to figure out which one it is. So in this case, it was this one. That's the one we want. So now we know our function is 3x plus 1, x plus 5. So we can set that equal to 0. So 3x plus 1 is 0, either this factor. So that means 3x is equal to minus 1. X is equal to minus a third. Or x plus 5 is equal to 0, which means x is minus 5. So you have two zeros, okay? One at minus a third and the other one at minus 5. So now you also know the y-intercept, obviously. The y-intercept is 0, 5. So you could already draw your graph, sketch your graph. So it would probably look somewhat like this. Let's say this is 5, this is minus 5, and this is a third. So your graph would probably look somewhat like this. So this is minus 5, minus a third, and here it's 5. And then you know that your vertex has to be in between the two zeros. So you could say minus 5 minus plus minus a third if you want, divided by 2. Well, that's minus 15 thirds, so it's minus 16 thirds divided by 2. So that's minus 8 thirds. So your xv, your x value of your vertex, is minus 8 thirds. Now you could plug this in here. Let's do that. F of minus 8 thirds is 3 times minus 8 thirds plus 1, and then minus 8 thirds plus 5. So this one here is minus 8 plus 1, so minus 7. And this one here is minus 8 thirds plus 15 thirds, which is minus 7 times 7 thirds. So we're going to get minus 21 thirds. Minus 21, minus 40, minus 49 thirds. 7 times 7 is obviously 49, minus 49 thirds. So your vertex is at minus 8 thirds, minus 49 thirds. So you could have done it like this. But oftentimes you'll use a method that we will introduce in a few lessons' time, and you will not do this, but because it was so easy here with 2 prime numbers, which give you only 2 possibilities, 1, 3 and 1, 5. So you have essentially 2 possibilities that you have to check in order to find your factorization. But obviously, if we had, for example, a 17 here, it would not have been possible. If this had been 17, this method would not have been possible. So there is always the other method, which is quite laborious, but very strong. Look, f of x is 3x squared plus 16x plus 5. Now look, here you have to factor out your 3x squared plus 16 thirds x plus 5. Now what do you do then? You complete the square. It's like these exercises up here. You see? So x squared plus 16 thirds x plus 8 thirds squared. You add half of this squared, minus 8 thirds squared, brackets close, plus 5. Now this will be your perfect square. And you could highlight this in red. Here we go, so that you can differentiate the two. Now f of x is 3 x plus 8 thirds squared minus 64 thirds, ninth plus 5. Then you have to distribute. So this times this and this times this. So you're going to get 3 times x plus 8 thirds squared minus 64 thirds. And then you have to add plus 15 thirds, which is 5, obviously. And you get f of x is 3x plus 8 thirds squared minus 49 thirds. See, and that's exactly what we got here. And then you could obviously work out the 0 by setting this one equal to 0. Let's do that. 3x plus 8 thirds squared minus 49 thirds is equal to 0. So first thing we do is x plus 8 thirds squared is equal to 49 thirds. Then we divide by 3. X plus 8 thirds squared is equal to 49 ninths. Now we take the square root. X plus 8 thirds is equal to plus minus the square root of 49 ninth. X plus 8 thirds is plus minus 7 thirds. And then x is minus 8 thirds plus minus 7 thirds. Now you get two solutions, one with the plus, which is minus 1 third, and the other one with the minus 8 thirds minus 7 thirds is minus 15 thirds. Look, this is quite a bit more laborious, but well, it will lead to the solution each and every time. And well, when I say you will not do this one if it's too complicated by trying to factor it, you will by then eventually do something like this, but this is very laborious. So we will do this once and for all with A, B, and C coefficients, and then we'll find a formula for this. That will be very, very interesting. So I hope this wasn't too difficult. See you on the next one.